we must have at least one point C between 0 and pi, somewhere between them, where the derivative f prime of C is equal to 0. And where is f prime of C equals to 0? Is right here. The derivative is the slope of the tangent line. What does your tangent line looks like? Horizontal. What is the slope of horizontal line? 0. So you go up there and you read that value. And if I look at my graph there, it looks like pi over 2 on the screen. So C must be pi over 2 there. Actually, they gave us the function even. They give you the graph and they give you the function. They give you both. So I'm saying the answer is pi over 2. Now, I didn't even see the function until I looked back there, and it says f of x equals negative sine of x. I missed it. I didn't see that till I looked back again. It was way on the bottom. So what's the derivative of that?
Do they give you?
They give you the scale on it.
Yeah.
What's the derivative of that? Derivative sine is what?
Cosine.
Cosine, that'd be negative cosine of x. Take that derivative, set it equal to 0. That means cosine of x is equal to 0. Cosine of what? Between 0 and pi. Let's see, there's 0 and pi. Where's the cosine equals? Where's the cosine? Yeah. Where's the cosine equals to 0? Cosine is the first number. What do you know? Pi over 2. So even if they didn't give me the graph, which they did give you the graph, so the first time I did it by the graph, the second time when I went to type the answer, I noticed right above the answer, below the answer, they wrote f of x equals negative sine of x. So that's when I came back and did it with the math. So this is negative pi over 2, not negative pi over 2. Symbol, pi.
You're just put PI too.
Type what?
PI.
Bi? Oh. 2.
Do they have a plus and minus symbol too?
Probably.
I couldn't find it. I don't know if anything else did.
Symbols. I'm just looking for plus minus to see. They have less than or equal, greater than, plus minus. No. I don't see plus minus, so that means you're probably going to type it twice, one with the minus, one with the plus with the comma between them. Yeah. That's number 3. Let me see, 6. Can we use Rolle's theorem here? They want to know if we can use it. And if we can, probably in the second part, I'm sure they're going to ask us for the value of C. Okay, Rolle's theorem says the function has to be continuous. Is this function continuous from negative 27 to 27? Here is the part in case you missed it. This is 1 over the cube root of x to the 4th. because this becomes x to the 4/3, which is the cube root of x to the 4th power. Can you tell me what the answer to this when x is 0? 0 is between negative 27 and 27. What is the answer to this when x is 0? Undefined. So the function is not continuous. So I can't use Rolle's theorem. But they have more than one answer. Do they give you more than one answer? Can you check more than one? Yes. For that one, they have a lot of checks. What's the derivative of that? Isn't that negative 4/3 x to the power of what? Subtract another 1 from it, which is negative 7/3. So that's negative 4 over 3 times the cube root of x to the 7th. What is the derivative when x is 0? Undefined. So that's not continuous either. The derivative. Can't take the derivative from negative 27 to 27, not a 0. And what's the third condition? The function has to be continuous. Here, not a 0. The derivative must exist, not a 0. And the third condition for Rolle's theorem, f of negative 27 has to equal f of 27. It has to be. Let's see if that's the case. So again, this is 1 over the cube root of negative 27 to the 4th power. I can put the 4th inside or outside. Either way. If you remember, x to the a over b is the b root of x to the a, or the b root of x, the whole thing to the a power. Either way. Either way. So I did this because I know what the cube root of negative 27. That's a negative 3. 1 over negative 3 to the 4th minus the 3. 1 over 81 minus 3. Don't worry about the value. Who cares? I want to know if it's the same as F27. One over the cube root of 27 is 3 to the 4th. What is 3 to the 4th? Are they equal? Yes, they are. So this test did not fail, but this one failed and this one failed. So the reason we can't use Rolle's theorem because the function is not continuous and the derivative does not exist.
Could you do, for mine I had x to the 2/3 rather than x to the negative. So
2/3 the function will be continuous. The derivative will not be. If you what's your range from where to where?
Negative 8 to 8.
Yep. The function is continuous actually because 2/3.
Yep.
There's no fractions. But when you take the derivative, that's going to be 2/3 x to the minus 1/3.
Okay.
And that will put on the bottom, and you can't take the derivative at 0.
So it's just
Will be derivative in your case. And the tricky part about this is, says, which I got it right there, I put both checks. This is, if Rolle's theorem can be applied, find C. So it makes you think there's an answer to that. But there's really no answer to it. Can't be. Number 6, 7, and number 8 are very similar. One is sine of x, one is cosine. Well, number 8 is actually more challenging, so I'll skip 7, I'll go to 8, because it's cosine 2x instead of cosine x. 7 is straightforward, so 8 will be just a hair more complicated than 7. So I'll go with the 8. Again, tell us if we can use Rolle's theorem here. F of x equals 3 cosine 2x. And it's from negative pi to pi. Quickly here, what cosine of x looks like. This is what cosine of x looks like. That's what cosine of x. This is 0, that's 2 pi. So 2 pi, this is actually pi, and this is negative pi. They went from negative pi to pi, so they're only interested in this portion. This one. That's cosine of x, not 2x. Oh, I don't know why I made it red. What is cosine 2x, or 3 times cosine 2x? Well, the frequency will be doubled. So by the time you go from here to here, you have one full cycle. And it's going to, bless you, it's going to be, the height is 3. So 3 cosine will look like this. That's on this end. That's that end. So that's the 3 cosine 2x from negative pi to pi. Remember, this actually changed the frequency. You'll have 2 sets of them by the time you go from 0 to pi. That's what that means. That number 2. Now it says, can we use Rolle's theorem here? Well, let's see. Looking at the picture, is f of x continuous from negative pi to pi? Is f of x continuous? That's the question. If the answer is yes, test number 1 is passed. Let's look at it. Do you see any holes in it from negative 1 to 1? No. That's good. How about the derivative? Does the derivative exist? Well, the derivative cosine is what? So there's the 3 sitting in the front. Derivative cosine is negative sine of 2x times the derivative 2x, which is what? 2, that would be what? Negative 6 sine of 2x. And notice the derivative exists. There's no value between negative pi and pi if I graph it. The derivative does not exist. So this one is good too. This one passed the test. This one passed the test. Step number 3. Does f of negative pi equals f of pi? Looking at the picture, the answer is what? Yes. So this one says there has to be at least one value between negative pi and pi. It has to be one number where the derivative is 0. And guess what? I see actually 3 of them. I see this one, I see this one, and I see this one. Derivative is 0. So if my scale is right, if I do this to scale,
why wouldn't pi or negative pi be 0?
huh?
Why wouldn't pi or negative pi be 0 also?
Pi and negative, well, for what?
For the 0 at the derivative.
Pretty much 2 endpoints you're talking about.
You can't count for this one?
No, I'm talking about why wouldn't it be 0 for negative pi and then pi for...
Well, it's you're only ending right here, right? You're ending the graph. You're not continuing with it.
Uh-huh.
So not the endpoints. It has to be a value between A and B.
Oh, okay.
between this value and that value where the derivative is 0. So it has to be between negative pi and pi, not including these, where the derivative is 0. Now looking at that picture, I see the 0 is one of them. And this value has to be between the 0. It looks like halfway, isn't it? Halfway between this and that. That's negative pi over 2. And this one looks halfway between the 0 and the pi, which is what? Pi over 2. So we have three values where actually, if you take the derivative of that at these numbers, the answer is 0. Let's see.
The only way you're going to get those values by making a graph and looking at it.
Nope, you can take the derivative, set it equal to 0. You know? You can go, okay, take my derivative. This says the derivative is 0. Take negative 6 sine 2x equals to 0. That means sine of 2x equals to 0. Sine of what is 0? So we have to look at it. Sine of 2x. Well, you can take the trig identity. Sine of 2x here is what? 2 sine x cosine x equals to 0. You divide by 2. Sine of x cosine of x equals to 0. You're multiplying. You want your answer to be 0. Set each one equal to 0. And see what the value. Now, again, you can only look between negative pi and pi. Where's my unit circle? Right here. This is negative pi on the bottom. Or negative pi, I'm sorry. Where's negative pi? Between, negative pi. If you're traveling this way, all the way to pi. From minus pi to pi. Let's see where the sine equals to 0. Sine of what is 0? Sine is the second number. It's the 0, and it's what? It's pi. I can't use the endpoints. Right? So 0 is one of them. Where's the cosine is 0? Negative pi over 2 right here. Can you see it? That's negative. If you're traveling this way, that's negative pi over 2. And that value is what? Pi over 2. So it's not just by the graph. You can do them mathematically and get the answers. If you have the picture, it's easier because you can look at it and see it. But also the math tells you there's three values. The sine is 0. And again, it can't be the pi and the negative pi. It can't be the endpoints. So 0, negative pi over 2, and pi over 2. So this one, yes, Rolle's theorem can apply. And you can plug in the values here. Negative pi over 2, and pi. Now, negative pi over 2, and 0, not pi. Number 11. Got three more questions. F of x equals 7 minus x from negative 9 to 7. Is your function continuous? Well, let's find what the domain is. What is the domain? I want to make sure 7 minus x is greater than or equal to 0. Do the math. 7 is greater than or equal to what? X, or x is less than or equal to 7. Is this function, is this range between 7 and less? So I'm good. What is the graph of that? If you were to graph that function I do have a graphing calculator, I'm just lazy. I'm sure the graph will look like this. This is the 7. Excuse me. And it will look like this. Is the function continuous? Yes. Step number 1, continuous. Step number 2, is there a derivative for it? Well, to find the derivative, let's write that f of x equals 7 minus x to what power? 1/2. So what's the derivative of that? 1/2. 7 minus x to what power? Negative 1/2 times the derivative, what's on the inside, which is what? Negative 1. And again, the only place where the derivative does not exist is what? 7 or larger. But the derivative has to exist on the open interval, not the closed interval. Does the derivative exist on the open interval? Yes. The only time this does not have an answer when x is 7 or larger than 7. I'm not using the 7 or anything larger than 7. And the next one, so step number 1 and 2 are good and good. Step number 3, is f of negative 9, does that equal to, question mark, f of 7? Probably not. F of negative 9, that becomes 9 and 7, which is what? 16, which is 4. What's f of 7? Square root of 0, which is what? 0. Are they equal? No. Does it say Rolle's theorem here? Oh, it doesn't say Rolle's theorem. My mistake. Mean value theorem. So, no Rolle's theorem. I got excited because I've been dealing with Rolle's theorem. Here, actually, the mean value theorem. The mean value, this does not have to be true. If it is, fine. It doesn't have to be. For the mean value, there's only 2 conditions, these 2. So for the mean value, yes, it is. You only have to satisfy 1 and 2. You only need conditions 1 and 2. And in this case, yes. And the mean value theorem says, you know what? There has to be a point, at least one point, between negative 9 and 7, somewhere there, where the derivative at that point is equal to, in this case, f of 7 minus f of negative 9 divided by 7 minus the 9, minus the negative 9. A minus B. So f of 7 happens to be what? 0 minus f of negative 9, which is what? 4 God. Over 7 minus a minus, which is what? 7 plus? What is 7 plus 9? 16? That's negative 1/4. So let's see if there's a value there. Take the derivative and set it equal to negative 1/4. And let's see if the value for x we get between these two numbers. If it is, Rolle's mean value theorem is good. Is correct. We can drop the minus sign, cross multiply. 1 times 4 is 4. divide by 2. To get rid of the square root, what do? Square both sides. To solve it for x, I can bring the negative x to this side, take the 4 to that side, x equals 7 minus 4, x equals 3. Is 3 between negative 9 and 7? Yes, it is, right? So they were right. Yes, we can use the mean value theorem. And yes, the x value is actually, what was it? 3. Same thing, 13 and 14, except with a trig here. I gotta rush through them because we have 2 more sections to cover tonight. Cosine of x plus tangent x. X between 0 and pi. Is the function continuous? Well, think about it. The tangent is what? Sine over cosine. Between 0 and pi. Can you see the unit circle? Because the tangent is sine over cosine. That's a fraction. Between 0 and pi, is there a value for the cosine where the value is 0? Yep, pi over 2. So it's not continuous. So that failed. Can't even use it. Failed test number 1. If you want to take the derivative, you'll see the derivative fails too. Derivative cosine is what? Negative sine of x. The derivative tangent is what? Secant squared x. Or you can write that. Secant is 1 over cosine. Cosine is not continuous at 0. Not continuous. Or it does not exist. Instead of not continuous, the derivative does not exist at 0. Does not exist at pi over 2. Fail that test. Test number 3, I can check it in. Is f of 0 equals f of pi, because they want to know which condition fails. Could be all 3 of them failed. What's f of 0? It's cosine 0 plus tangent 0. Here's cosine of 0, which is 1. The tangent of 0, tangent is sine over cosine. 0 divided by 1 is 0. The result is 1. Let's see f of pi. That's cosine pi plus tangent pi. Cosine of pi, this is pi, the cosine is negative 1. The tangent of pi is the sine over the cosine, 0 over negative 1. 0 over negative 1 is 0. That's a negative 1. That also failed. They're not equal. Oh, we're doing base theorem here, or mean value?
Yeah.
Wasted my time on it. I don't need condition 3. So Rolle's theorem failed. And the mean value failed. Both failed. This is actually the last one. The third one is for the Rolle's theorem. I keep forgetting here with the mean value theorem. So failed and failed does not exist. Let's see if I can remember. The last one is the mean value. So remind me it's the mean. So I don't have to check the third condition, waste the time on it. Uh-oh. Oh, F, not F prime. Arc 9 minus x. In case you forgot your derivative, arc of u, it's u sub prime over 1 plus u squared. Arc of u, the derivative of that, it's u sub prime over 1 plus u squared. U here is 9 minus x. So my derivative, I'll check to see if this is continuous in a minute there. I got excited when I saw this. The derivative 9 minus x, which is negative 1 over 1 plus 9 minus x squared. I'll come back to it later. And they want it from where to where? I told you, I got so excited I forgot the rest of the problem. 8 to 9. Is the function continuous from 8 to 9? Is there a value for arc from 8 to 9? As x goes from 8 to 9. Well, you might probably have a hard time graphing this. You can actually save yourself a little bit by changing that problem. If you want to change it, you can do this. Take the tan of both sides. What's tan arc 10? They cancel each other out. You know what? If I did the derivative, it would be a lot easier. And replace it with, you know. So when x is 8, let's see if this for like anywhere between them. Can you find a value for x? This is what you're looking at. By the way, in case you're wondering what you're looking at, you're looking at an angle which is called y. You're looking at that angle, and the tangent of that angle is the side that's opposite. That has to be 9 minus x here. And this is the 1, because it's 9 minus x over what? Tangent is opposite over adjacent. That's what you're looking at. Can we find what this side equal to? Pythagorean's theorem, isn't it? So if you want to find that side, you can. But that's really what you're seeing there. Tangent y. But let's look at this function, arc tangent. Plug in values for it. We're going from 8 to 9. If I plug in 8 here, can you take the inverse tangent? What is 9 minus 8? 1. Can you do on your calculator the inverse tangent of 1? Shut up out there. Yep, there's a value for it. Can you do the 9? Arc 10, second 10, 9 minus 9, which is what, 0? Yep, there's a number for it. How about like 8.5? Second 10, 8.5. It looks like I'm good. Every number I'm putting between 8 and 9, I'm getting an answer. I don't see any number where if I plug it in, I'm not going to have an answer to it. So test number 1, is this function continuous? Yes. Does the derivative exist? Yes. From 8 to 9? Even if I plug in 9 or 8 here, would that work? Sure. Why? Because look at the bottom. You're squaring a number. If you square it, the value is what? 0 or larger. So the smallest value you can have is 0. When you add 1 to it, it's going to be 1. So this will never be undefined. Never. The bottom will never be 0. And it doesn't matter how you slice it. So that's good too. So we did pass the test. Yes, the mean value theorem can apply. And now if you want to find what the value is, you take the derivative, set it equal to f of 9 minus f of 8 over 9 minus 8. Let's see what that derivative, f of 9. I forgot what that value. Arctangent, when it's 9, that's a 0, right? What's arctan? Up. Arctan of 0. That's 0. Minus arctan 1. 0.78538 over 1, negative 0.78539. Set the derivative is equal to that. Cross multiply. I can drop the minus to make it a plus here. 1 times 1 is 1 equals 0.785391 times 1 plus 9 minus x squared. So divide by that number, 1 divided by that number, 1.27324 roughly, I'm rounding here, equals 1 plus 9 minus x squared. Subtract the 1 from both sides. 0.27324 equals 9 minus x squared. Last step, or 2 steps, 9 minus x will be plus or minus the square root of that number. What is the square root of that number? 0.5227, some change there. Bring the negative x to this side, bring that here, x equals 9 plus or minus 0.5227. I can't use the plus because I'll be outside my range. But if I use the minus, what's 9 minus that number? 8.4772767799. I carried all the digits when I was doing it. And that's what x is equal to. If I do the plus, I would be outside my range and I can't use it. Hopefully they'll let us put like 3 decimal places for yes, we can use it. Find the value of c, I don't know, Enter your answer as a comma, round your answer to 4 decimal places. It says 4 decimal. I was like, don't tell me. 8.4727 is it? Yes. Done.